This is lecture 6 in signals and systems. So in this previous lecture 5, we have solved some problems on operations on different signals, right? So in this lecture we are continuation of the signals only. I mean different types of continuous signals. We have discussed some signals like unit step, delta t, that is unit impulse, ramp signal, that is r of t, etc., and exponential signals e4 at, right? Now we are going to see some more signals in signal systems and continuous signals, but before that, so this is our blog, that is learning is everything.blogspot.in. I uploaded previous GATE question papers, that is 1991 to 2000, right? I will also upload from 2001 to 2016 in next few days, right? So please go through these question papers, download it. Next, I also uploaded solution to nodal analysis problems in network theory, right? So go through these solutions. If any doubts, you can post a comment there, and then we can discuss, right? Now we'll see the one by one what are the signals. Now first we will see what is this parabolic signal, or generally we say unit parabolic signal. So then this definition, or we can say equation from x of t is equal to, I can write t square by t for t greater than or equal to 0, and it is 0 otherwise, right? So this type of signals can also write, see, when t greater than or equal to 0, so this is the unit step function limits. So this x of t, simply we can write t square by 2 into u of t, because u of t is like this. This is t, for t greater than 0, this is 1. So whenever any signal is t greater than or equal to 0 is some value, that value can be multiplied with the u of t. Now how to draw the signal waveform, that is t, and this is x of t. We know that this is a parabolic signal. Depending on this slope, or we can have different like this also, right? So suppose this is x1 of t and this is x2 of t. So different points we will get different amplitudes like this, right? So this is the parabolic signal. Next, very important, this signal, or we can say signal function. So this is also can be represented by like this: x of t is equal to 1 when t greater than 0. It is minus 1 when t less than 0. So that means this is also can be written like this. So x of t is equal to, so generally this signal function can be denoted by sgn of t. Signum of t is equal to, see, for t greater than 0 we can write u of t, plus for t less than 0, so this is minus 1, so we can say minus of u of minus t, or u of t minus u of minus t. Why what is this is so what is u of t? This is the u of t, this is t. Similarly, what is u of minus t? Reversal of this. So this is u of minus t, this is t, but we need minus 1. So minus 1 means we have to subtract these two, right? Then only we can get like this. This is t, 1 minus 1. This is the signum of t. This is t. This is the signum function, right? So signum function, generally we say sgn of t is equal to 1 when t greater than 0, minus 1 when t less than 0. So this can be representable like this. Other way of representation of signum t can be like this: signum of t is equal to minus 1 plus 2 into u of t. Now how? So 2 into u of t means, we know this is multiplication with the 2. This is 2 into u of t. This is t. What is minus 1 means? So minus 1 means this is t, So for minus infinity to infinity we will get minus 1. Now if you see up to here, this is 0, this is minus 1, we will get minus 1. Now from up to here, minus 1 plus 2 will get plus 1. So this is also signum of t, which is minus 1 plus 2 into u of t, right? This also can be write like this also. Now I'll write here. So other way of signum of t is equal to 1 minus 2 into u of minus t. So this is also can be proved, that is, this is 1, and if there is a signal with minus 2 into u of minus t, we know that u of minus t is like this, so this is minus 2 into, so this is minus 2 into u of minus t. Now similarly if you add here, so 1 minus 2 we will get minus 1, right? If we add here 0 plus 1, so 1, so it is also signum of t, right? So three ways we can write signum function: u of t minus u of minus t, 1 minus 2 into u of minus t, minus 1 plus 2 into u of t. So three ways we can write, or we can write simply as like this also, right? So that is about the signum function. Next we will see two important function, that is sinc function and a sampling function. Sometimes these two are will write same. So sinc function can be represented by sinc t is equal to sin pi t by pi t when t is not equal to 0, and it is 1 when t equal to 0. I will prove that one. Sometimes sinc function can also written like this: sinc t is equal to sin t by t when t is not equal to 0 and 1 otherwise or t equal to 0. That's why this is also called sampling function SA of t, right? So that's why this sinc t and this sinc t will confuse. That's why when sin t by t is there, we can say the sampling function SA of t, right? Now how to get a t equal to 0, what is the value? So if I take sin pi t by pi t, so I cannot substitute t equal to 0 because 0 by 0 form. So using LH rule, so differentiation in numerator and denominator. So pi into cos pi t by pi. So cos 0 is 1 and pi by pi, so we will get 1. So that is t equal to 0 at 1, right? Now so how to draw the graph t? This is sinc t, right? So this will be like this, and it is symmetric about this imaginary axis, whatever this one, and also this will be same, that is symmetric, or we can say even signals. At 0 we know that this is 1, and what are these points that is like this? So where the sinc function is becoming 0. It's very simple. Sin pi t is equal to 0, so we can say sin n pi. So sin pi t is equal to 0, which is equal to sin n pi. That means when t is equal to n different, so that is 1, 2, 3, 4, etc. minus 1, minus 2, minus 3, etc. Right? Suppose if they ask what is the area of sinc function, area of sinc function is 1 directly, right? If we integrate from minus infinity to infinity, we will get 1. So that is minus infinity to infinity. If we integrate, so that is from the integration formula, we will get area of this one is 1, right? So that is about this sinc function. So in detail we have to discuss again in the Fourier transform. So see here also sin t by t can be denoted by like this. This is t, this is SA of t. So same waveform will be there, so like this, and here also 1 sin t by t can be not be directly substitute t equal to 0, so LH rule will apply, so we'll get 1. but here the points where the sampling function will become 0 is, so sin t by t is equal to 0 or sin n pi, right? So when t equal to n equal to 1, so pi, 2 pi, 3 pi, etc., minus pi, minus 2 pi, minus 3 pi, etc. This is sampling function or other way of sinc function, right? Suppose someone asks you draw this a sinc t, right? So it will become a into sin pi t by pi t. So the graph will be remaining same like this only, but the amplitude will become a at 0, and the area will never change in sinc function. Area is always 1 only. So the amplitude will become a at 0 only, otherwise the area will be 1 only, right? So this is about the sinc function and sampling functions. Next we will see the even and odd signals. So we'll get frequently questions on this even and odd signals. So very simple. So even signal. So even signal, how can we say some given signal is even or odd? So if x of t is equal to x of minus t, that is, if I reverse the given signal, if it is equal, then we can say it is an even signal. So if it is satisfying this condition, so we can say it is an even signal. Similarly, odd signal, if the reversal is negation of this one, so if x of t is equal to minus x of minus t, so we can say x of t is a odd signal. So examples like this. Suppose you can take sinc function, very simple, but if I take like this, minus 1 to 1, this is 1. Suppose this is x of t, right? What is x of minus t? So from minus t means reversal. For whatever the positive time axis, it will be goes to negative, this minus 1, similarly this one. So we will get same, right? So this is x of minus t. So x of t is a even signal. So what is about odd signal is, suppose a given waveform is like this, minus 1 to 1, 0, 1, this is 1, 1, minus 1. So this is x of t. So this is type of signals are odd, because if I take x of minus t, so what you will get? So from 0 to 1 it will goes to plus 1, minus, the negative axis 0 to minus 1. Similarly from minus 1 to 0 it will goes to opposite. This is t. Now if you compare this and this, if I negate, that is from here minus x of minus t, then it will become the opposite. So this is a positive, it will become negative, and this is positive, it will become negative. So these two are equal, right? So that's why this signal is a odd signal, right? Now how to find even and odd? So any x of t can be written by x even of t plus x odd of t. So summation of odd signal and even signal can be represented by the signal, the main signal. So x of t can be here x of t plus x of minus t by 2 plus x of t minus x of minus t by 2. So this is x of t can be represented by. So this is the even signal x of t, and this is the odd signal x naught of t or xo of t. So in the questions they will ask find even signal, find odd signal, etc. Right? So the problems we will do later. First we will discuss the concepts wise. Right? So this is about even and odd signals. Next we will see the periodic signals. So suppose if x of t is shifted by some time, x of t plus t, so it should be same as the given signals. Then we can say x of t is a periodic signals and t is a time period t, right? So periodically it will be same. So if I shift the original signals, the original signal should not change. Then we can say this signal is called periodic signal. So we take a signal like this, suppose this is 0 and this is t, here minus t, etc. So it should be up to infinity, it should not be fixed to some points only. So this is suppose x of t, this is t, right? If I right shift or left shift, so this is left shift we are doing by t. See, wherever t is there, we have to add minus t, 0 minus t, minus t, minus t. So what we will get? So this total will be shifted to 0 and this will be shifted to minus t and this will be shifted to minus 2t, and whatever here signals that will be shifted to, so suppose if I take 2t here, so minus t, so 2t minus t will get t, right? This is t, so up to infinity. So x of t plus t is also is nothing but x of t, so this is a periodic signal. Suppose if I do the right shape, that is x of t minus t, then also we will get same, this will be shifted to t, that is like this, and minus t will become to 0 and so on. So the original signal never change when you shift any time, right? This is minus t, 0 t, 2t, etc. So this is like a periodic signals, right? So it should not change. And what is the time period? Whenever it is repeating, at what time it is repeating, that is generally we say periodic time period or just period, right? Next we will see complex exponentials. Complex exponential signals. So suppose some signal is here, x of t is equal to c into e power at. If c and a are real, we can say this is a real complex exponential, real exponentials that we have already discussed. If c and a are real, and x of t is called real exponential signals, right? So this is already we discussed. Anyway, I discussed one more time. So real exponential signals can be represented like this, right? This is e power minus at, and this is when it is growing, so we can say x of t is e power at. This is t. Now at t equal to 0, so if it is c into e power at, so we will get c here. Here also we will get c here. If 1 is there, 1 we will get. So this is about real exponential signals. So what about the complex exponential signals, right? Suppose both are in complex, right? If x of t is equal to c into e power at and c comma a are complex variables are complex, so it is like this. C is equal to suppose some magnitude into some angle. Similarly a is also suppose r plus j omega. It's a complex number, it's also a complex number. So x of t can be represented by like this, mod c e power j theta into e power r plus j omega t. So this can be represented like this, mod c e power j theta into e power r into e power j omega t, right? So by Euler's relation we can write like this. So this is e power j theta, so mod c e power r, right? This is t, so e power rt, so e power rt into e power j omega t plus theta. Now by Euler's relation we can write like this, mod c e power rt into cos omega t plus theta plus j sin omega t plus theta. Now suppose if r is equal to 0, x of t is in sinusoidal signals only, that is cos omega t plus theta plus j sin omega t plus theta. So we can say this, I can write like this. So it's a purely sinusoidal signal, so I can write something like this. So the amplitude will be same. This is x of t when r is equal to 0. Suppose next case, when r is greater than 0. So when r is greater than 0, x of t is mod c e power rt into right, j omega t plus theta. So this can be represented by cos omega t plus theta. That's not right. If r is greater than 0, this whole term will be growing exponential. So we'll get a signal something like this. So exponentially growing sinusoidals will get like this, right? Something like this when r is greater than 0. This is the complex exponential. Similarly, when r is less than 0, we'll get decaying exponentials. That is like this, right? Something like this. This is t, and so on. This is the decaying exponential, and this is the growing exponential, which is unbounded, or I can say unstable. Next one we'll see complex periodic signals, right? Something like that. So you can say this one is part B, that is complex periodic signals. So very important one. So suppose x of t is equal to e power j omega naught t. See, this is a periodic signal. This type of signals are generally we say periodic signals. So what is the fundamental period? So how to find? Suppose we know that x of t plus t should be x of t, that is e power j omega naught into t plus t. So this will become what? E power j omega naught t into e power j omega naught capital T. So to be equal to x of t, this should be equal to 1, that is e power j omega naught t is equal to 1. Then we can say x of t is periodic. Now we know that. So how this will become 1? So when suppose it will be represented like this, e power j 2 pi, this one, so e power j omega naught t. Suppose if it is represented by like this, j 2 pi. So omega naught t equal to 2 pi means we will get cos 2 pi plus j sin 2 pi. Always we will get 1, that is cos 2 pi plus j sin 2 pi. This is 0, so cos 2 pi is always 1. So cos 2 pi n actually. So we can simply, the smallest period or smallest integer to get this one is as 1 is 2 pi. 3 pi is not by 4 pi etc. So we'll get that one. So what is omega naught? So omega naught t is equal to 2 pi. So what is t? 2 pi by omega naught is the fundamental period. Fundamental period. Remember why I have taken only 2 pi? The smallest possible integer we need to take. That for smallest integer we can have a time period t, or we can say fundamental. So it will be 4 pi also, you say we will get 1 only, but that is not the smallest integer, right? This omega naught, so generally it may be positive or negative, so that's why we will put mod. Now that means e power minus j omega naught t, e power j omega naught t, both are periodic signals, right? Next one, there's some very simple one. The sinusoidal signals, everyone knows sinusoidal signal. So it can be represented by x of t is equal to some a into cos omega naught t plus theta or pi. So phi, this one is a phase shift, right? So simply we can write like this representation. At 0 we will get a, and so on. So what is these values? Now when omega naught t equal to 0, so this will get to pi by 2, 3 pi by 2, right? So the period will be pi, right? So that is about the, this is pi by 2, this is some pi, see, or we can say up to here it's a one period. So this is generally we say 2 pi is the periodic or a time period of a sinusoidal signal. So we can represent a into sine omega naught t plus theta also. So up to here, this maximum to maximum we can say period, right? Now next one is power and energy signal. So this is a very important topic in signals system. So more frequently we will get they find the energy of a signal, find the power of a given signal, etc. Now before that, we know if voltage and if I know the current across any resistor, now what is the power? Power P is equal to V of t into I of t. Now how to represent in other way? V of t square by R or I square of t by R. In the physical world, generally we say some voltage and current waveforms only, because when I convert from mechanical energy to electrical energy, right, or some Y signal to electrical energy, different we'll get electrical signals as in the form of either voltage or current. So that's why the power is either V square by R or I square by R. Now what is the energy? So energy, we have to integrate the power dt. This is already we have seen in the network theory, right? If I integrate the power from fixed point of time, that is t1 to t2, right? So we can get a power. If I integrate a power, then we will get an energy. Now if I apply this concept for a general signal, generalized version, so for R is equal to 1 ohm generally, right? So this represented by like this, P is equal to simply x square t, right? Or we can say simply for I square r t also it will become x square t. That is for a signal x of t, generalized expressions we are writing, right? First I am writing the energy. Energy is equal to, so generally the physical signals, it will come from minus infinity to infinity, different signals, something like this or whatever, right? This is some x of t. So we have to integrate from minus infinity to infinity, and the power is x square. So we can say sometimes mod, that is mod x square t dt, or mod of x square, right? So this is the energy of a given signal, right? So this is about the energy. Now I already discussed energy is different, power is different, right? So when you are having power and when you are having an energy in you, how much energy you are wasting on a particular task is called the power, right? So you are having from minus infinity to present time or whatever, so you are having energy. So how much energy are you wasting on a particular time for a different task? So that is called the power. So we have to integrate with how much time or what are the time you are spending that energy. So that's why I am writing limit t tends to infinity and 1 by 2t minus t to t. That means minus 2t t to t, that is I am spending from this one minus 2 to 2. So what is this total time period or time width 2t? So that's why 1 by 2t, because we know that energy is equal to power is equal to dw by dt, right? So we have to this energy should be divided by the time. So how much time we are spending the this energy. So that's why we are getting the 1 by time, right? 1 by 2t integration of minus t to t, and this energy will be same, that is mod x square t dt. This is the power for a given continuous signals. So that is x square t dt. So you have to remember this on this. I hope you got the main concept, that is from this one. So v square by r, I square by r. For generalized expressions we have to take for p, this is x square t, x of t into x of t, right? So if I integrate the power, I will get the energy. Now if that energy spending across some time, that is 1 by 2t, so we have to integrate this minus t to t mod x square t dt. So this is the power and this is the energy, right? Now there is a classification of this, that is how can we say energy signal, how can we say power signal. So a signal can be defined by the energy signal if the energy is between 0 less than e less than infinity. That means energy is finite, right? And the power p should be 0. Then if these two conditions are satisfied, then we can say this is an energy signal. Next, similarly, power signals will be there. Power signal, if the power is finite, that is 0 less than p less than infinity, and that is p is finite, the power is finite value, right? And for the power signals, energy is infinity, then we can say this is a power signal, right? So one more signal is there, neither energy nor power. If energy is infinity and power is also infinity, then we can say neither energy nor power signals, right? So this type of signals will be there. If you find the ramp signal, so example, the ramp function x of t is equal to r of t, right? So you can find the energy. Suppose energy is equal to r of t is 0 to infinity and it is t square dt, because r of t is equal to t. Now this will make a t cube by 3, 0 to infinity, we will get infinity. Similarly, if I find power, so limit t tends to infinity 1 by 2t, integration of minus t to t, t square dt. Again we will get t cube by 3, this is minus t to t. So what we will get, t cube plus t cube. So 2 capital T cube by 3 into 1 by 2t. So t cancel, we will get t square by 3, and this t is infinity, so again we will get infinity only. So the ramp signal is neither energy nor power signals, right? Now to get the energy and power, we have to know the integration formulas. So right, so when we know the integration formula, suppose some 0 to t, some e power t dt is there. So what is the exponential integration? We will get exponential only. Some formulas we require. When we do power problems, then we can discuss those exponential or whatever the different integration required, right? So this is about the power and energy signals and different kinds of signals, right? So next lecture we will see some problems we'll solve by these concepts, right? How to find a periodic of a given signal, etc.